In the first video on simultaneous equations, we looked at solving linear simultaneous equations by the method of elimination. In this video, we're going to look at substitutions and rearrangements. Let's recap now what we looked at in the last video. So let's take now one equation, 4x minus 5y is equal to 5. So this is a linear equation. So I've got no powers of x and no powers of y above 1 and no multiples of x and y. At the moment, I can't solve this equation. I need at least two equations to solve the two unknowns. So if this was just in terms of x, we could look to solve it. If it was just in terms of y, we could look to solve it. If we got two unknowns, we need at least two equations. So let's now have 2x minus 3y is equal to 2. So this is going to be equation 1 and this is going to be equation 2. With the method of elimination, we make either the x's the same or the y's the same. The easiest thing for me to do here is simply multiply equation 2 by 2. If I do that, I can make the x's the same. So what I'm going to have when I do that, equation 1 remains as it is. We have 4x minus 5y is equal to 5. We don't do anything with that one. And we simply multiply all of the terms in equation 2 by 2. So 4x minus 6y is equal to 4. And that becomes now equation 2. Once the x's are the same, I'm simply going to do equation 1 minus equation 2, as these are both positive values. If the signs are the same, we subtract. If they're different, we add. What we're looking to do here is eliminate x and solve an equation in y. Once we have a value for y, we can substitute back in to get x. So this is all recapping the last video. So if I do 4x minus 4x, I'm going to end up with 0. If I do now negative 5y and subtract negative 6y, that's going to give me plus 1y. And then 5 minus 4 is going to give me 1. So we can see from here that y is equal to 1. I now need to solve for x, and I simply need to plug it into any of the equations just here. So all I'm going to do is substitute in. I can substitute into this one, this one, this one, or this one. It really doesn't matter. So let's take now this equation here. So what we're going to have then is 2x minus 3y. Well, we know that y is equal to 1. We solve for y, and we know that that will be equal to 2. At this stage, I'm simply going to add 3 to both sides of the equation. So 2x is equal to 5. Dividing both sides of the equation by 2, x is equal to 5 over 2, or 2.5. We would just go ahead and check that that works for both of the equations, and we would have the solutions to our linear simultaneous equations. So nice and straightforward, that's what we did. What we're now going to look at is an alternative approach. Let's take x plus y is equal to 1. X minus y we'll say is equal to 5. Before, we would have simply added these equations. If I add these equations, we're going to eliminate the y's. Plus y minus y will give us 0. So if I did that, I'd have 2x is equal to 6. X would be equal to 3. We'd substitute back in to find y to be negative 2. What I'm going to do instead, though, is rearrange one of these equations. I'm going to take equation 2. I'm going to leave equation 1 alone, and I'm going to write that equation 1 is x plus y is equal to 1 as it was before. With equation 2, what I'm going to write now, adding y to both sides and subtracting 5, that y will be equal to x minus 5, and that's equation 2. So all I've done is rearranged y in terms of x. At this stage now, what we can do is substitute equation 2 into 1. So we can do 2 into 1. So if I do equation 2 into 1, we're going to have in equation 1 x plus, well, we now have an expression for y in terms of x, which is going to be x minus 5, and that will be equal to 1. So what I've done by substituting is eliminated y. So we can see from here now that 2x minus 5 is equal to 1. Adding 1 to both sides, 2x is going to be equal to 6. Dividing both sides by 2, x is equal to 3. We can substitute this into either of the equations to solve for y. So if I take this one, y is equal to x minus 5, so that's 3 minus 5, which gives us that y is equal to negative 2. So there are the two solutions. I personally think it's easier just to add the two together to eliminate y. This is just an alternative approach and can be really beneficial when you have a linear and non-linear equation. So what we're doing is looking at substitution. So that's one way of doing it. Okay, let's look at another one. Let's say we've got now 7x minus y is equal to 1. And we've got 8x plus 5y is equal to negative 5. So this is equation 1 and this is equation 2. What we might have done before is just multiplied this equation up by 5. That would have made the y terms the same. Absolutely, we can go ahead and do that, and it's still a very valid and quick way of solving linear simultaneous equations. What I'm going to do though is rewrite equation 1. I'm going to add y to both sides and then now subtract 1. So I can write that y will be equal to 7x minus 1. So that's just rearranging, and that becomes equation 1. Now we have equation 2, which remains 8x plus 5y is equal to negative 5. I can make the substitution. I can put equation 1 into equation 2. If I do that, I have this expression for x, so we can say now that, or I should say for y in terms of x, 8x plus 5 lots of y. Well, y is now 7x minus 1, and that will be equal to negative 5. So that's what equation 2 becomes once we substitute in. So if I look at this, this is going to give me 8x plus 35x minus, then we're going to have minus 5, and that's going to be equal now to the negative 5 here. So from here what we can see is that the negative 5s are going to cancel, so we have 43x will be equal to 0, which means that x will be equal to 0. So from here I can simply substitute that back in, and we can substitute it back into this one here. We know that y is equal to 7x minus 1, so y would be equal to 7 lots of 0. Then we're going to subtract 1, and we can see that y would be equal to negative 1. So let's check those values work in both equations. So if we look, we said x is equal to 0, y is equal to minus 1. So x is equal to 0, y is equal to negative 1. So if we do that, what we're going to have, 7 lots of 0 is 0. Then we're going to have subtract negative 1, which does give us 1. So we know it works for that one. 8 lots of 0 plus 5 lots of negative 1 does give us negative 5, and it works for that one. So this is just an alternative approach. Let's do another one. Let's go for this one, 3x. So 3x is equal to 1 plus y. We'll take 5x minus y is equal to 3. Okay, so let's go for these ones. This is going to be equation 1, and this is going to be equation 2. I've got a couple of different choices here, and I'm going to look at this a few different ways. The first way is to rewrite equation 1 as y is equal to 3x minus 1. So on equation 1, y is equal to 3x minus 1, and that's equation 1. What I'm now going to do is substitute that into equation 2 to eliminate the x's. To eliminate the y's. So 5x minus y, well, y is now the 3x minus 1, and that will be equal to 3. So being careful here, we've got 5x minus 3x, which is going to be 2x. We've got minus negative 1, which is going to give me now plus the 1, and that's equal to 3. Subtracting 1 from both sides, 2x is equal to 2, and x is equal to 1. I can now substitute that back into either one of these. I'm going to put it in this one. We can say that y is going to be equal to 3 lots of x, which is 1, minus 1. Y is going to be equal to 2. So that now is done. So that's one way of doing it. So all I've done is rearrange and substitute it in. Does that work? 5 lots of 1 minus 1 lot of 2 is 3, so it works for this one. And if we take now 3 lots of 1, that will be equal to 1 plus 2, so it works for that one. So that's one approach. We could have done this a couple of other different ways. I could have rewritten equation 1 as 3x minus y is equal to 1. And then we've got 5x minus y is equal to 3. So this is equation 1, this is equation 2, and we could have done elimination. So what I would have done is just rewritten equation 1 below. So we would have 3x minus y is equal to 1. So that's equation 1. And simply subtracted equation 1 from 2. So if we do now 2 minus 1, what we'll end up with, 5x minus 3x is 2x. If we now subtract downwards, that will give us 0. And this is going to give us now 3 minus 1, which is 2. X is equal to 1. And we can substitute back in to go ahead and solve from there. So all we're going to do is simply look at solving, and we can go and find our value. So which one shall I put it in? It's entirely up to us. Let's put it in equation 1. 3 lots of x minus y is going to be equal to 1. So I'm going to subtract 1 from both sides and add y to both sides. Y is equal to 2. So that is an alternative approach. What we could have done, yet another way, is to make y the subject of both. So equation 1 would be y is equal to 3x minus 1. Equation 2, adding y to both sides and subtracting 3, we could say that y is equal to now 5x minus 3. If y is equal to this expression of x and y is equal to this expression of x, we can write therefore now 5x minus 3 will be equal to 3x minus 1. Subtracting 3x from both sides, 2x minus 3 is equal to negative 1. Adding the 3 to both sides, 2x is equal to 2. Dividing both sides by 2, x is equal to 1. And then just substitute back in. So you can see 3 different ways of doing it. Essentially they all lead to the same thing and have very similar techniques. So your choice. With linear simultaneous equations, you can use rearranging and substitution. You can use elimination, or you can rearrange and just get y as now a function or an expression for x and set these equal. Okay, let's do some more. Let's say I've got now 9, so 9x is going to be equal to negative 3y, and then we'll have 5, let's say we've got 5x plus 3y plus 4 is equal to 0. So we'll call this one equation 1 and this one equation 2. We've got lots of different choices here. What I could do at this stage is simply rearrange. So if I rearrange, I've got 9x plus 3y is equal to 0. I've got now 5x plus 3y plus 4 is equal to 0. So we could use the method of elimination as the y's are the same, the signs are the same, so we're going to subtract downwards. So 9x minus 5x is 4x. We're going to have 0, and then what we're going to have now, just think this is plus now 0, or we could even write this over the other side now. In fact, let's go ahead and change that. Probably easy if you want to see it this way. Again, entirely up to you. So 9x plus 3y is equal to 0, and 5x plus 3y is equal to negative 4. So all we're doing is simply now subtracting downwards. So we'll eliminate the y's. 0 subtract negative 4 gives me 4. So x is going to be equal to 1. And then we can go ahead and solve for y. So all I'm going to do is go ahead and put in x is equal to 1 into any of these equations. So if we look at the top one, we've got 9 lots of 1 is going to be equal to negative 3y. So we can say that 9 divided by negative 3 is going to be equal to y, and y will be equal to negative 3. So that's one way that we could do it. Alternatively, what we could have done at this stage is used a substitution. So what I could have done is just written this. Now, equation 1, we could have said now, dividing both sides by minus 1, that 3y is going to be equal to negative 9x. And I would simply substitute this into equation 2. So what we've got then is the following. We've got that 5x plus 3y, which is now going to give us minus 9x, plus 4 is equal to 0. So 5x minus 9x, we've got negative 4x plus 4 is equal to 0. So we can say 4x is equal to 4 and x is equal to 1. At this stage we can substitute in and again solve for y. An alternative approach is to get an expression for 3y. So what I could write is that 3y is equal to negative 9x. And also with this one now that 3y is going to be equal to negative 5x subtract 4. We could then go ahead and set these equal, as I've got an expression for 3y. So from here, negative 9x is equal to negative 5x and then minus 4. Adding 4 to both sides and adding 9x, 4x is equal to 4, x is equal to 1. Then we would substitute in to go ahead and solve for y in exactly the same way as we've done before. Do make sure that you're getting now more than just x or more than just y. You need x and you need y. So different methods, all essentially doing the same thing, and it's your shout on them. Let's have a look at this one. Let's go for, we'll go for 3y minus 15, and this will be equal to 6x. And then we'll take 2x, so 2x is equal to 7 minus 2y. We'll call this one equation 1 and this one equation 2. So what we could do is go to elimination. So on this one I could write that 3y minus 6x is equal to 15. So I'm just rearranging it, subtracting 6x from both sides, and then I'm going to add now the 15 to both sides. With this one we could add 2y to both sides, so we'd have 2y plus 2x is going to be equal to 7. We could then look to solve these. Now one advantage of this is that we could actually go ahead and divide all of equation 1 by 3. That would leave me y minus 2x is going to be equal to 5. Equation 2 is 2y plus 2x is equal to 7. So at this stage we have the x's the same. The signs are going to be different, so we add them. So we do 1 plus 2. That's 3y is going to be equal to, these will eliminate, 12, and y will be equal to 12 over 3, which is 4. Substituting back in, I'll put it into any one of these. I'll put it into equation 2. 2 lots of y, which is 2 lots of 4, plus 2x is going to be equal to 7. So we can say that 8 plus 2x is equal to 7. Subtracting 8 from both sides, 2x is equal to negative 1 and x is equal to negative 1/2. Just check that they work in both equations. Y is equal to 4, x is equal to negative 1/2. So if we wanted to put it into this one, x is equal to 4 and y is equal to negative 1/2. So if we look at that, that would be 12 minus 15 is going to be equal to minus 3. Just substituting, let's get that right rather than get that wrong. That's I put in the wrong values. Let's put them back in. Let's put y, so this will give us minus 3 over 2 or minus 1/2. Minus 15 is going to give us now on here, just substituting the value of x in. Let's put the value of x in, is going to be equal to 24. So let's go ahead and check that. Okay, let's just check, have I got the right values in? Let's check, right, okay, y is equal to 4, x is equal to negative 1/2. That's probably why that doesn't look like it's going to work, so let's change that over. So do check, as you can see, as I'm getting on in the video, I'm kind of getting a bit slack. So what did we say? X was negative 1/2, so x is negative 1/2, so let's check that. And this is why it's always worth checking. So x is negative 1/2, y is equal to 4. So is that going to work? Well, 3 times by 4 is 12. We're going to subtract 15 now from that. So 15 from that. Does that equal now negative 3? Yes, it does, as x is negative 1/2. Does it work in this one? Negative 1, if we substitute this in, is equal to 7 minus 8. Yes, it works for that one. So just be careful. As you can see, I didn't write them down correctly and made mistakes. So that's one way we could have dealt with that one. Let's look at dealing with it a different way. So if we pick it up at this stage right here, I've got some alternative approaches. What I could do right here now is simply divide the top one by that 3. So we'd have y minus, and then we're going to have 5 is equal to 2x. And then with this one now, we're going to have equation 2. We've got now, and I'm just going to write this slightly differently, 7 minus 2y is equal to 2x. So we've got an expression for 2x and 2x, so we can say, therefore, y minus 5 is going to be equal to 7 minus 2y. If we add 2y to both sides and then write this as 3y is minus 5 is equal to 7, 3y adding 5 to both sides is 12, y is going to be equal to 4. We're going to substitute that back into any one of these, so let's put it into equation 2. 7 minus 2 lots of 4 is going to be equal to 2x. So we've got 7 minus 8. 7 minus 8 gives us negative 1. That's equal to 2x. And we can see x is negative 1/2. So that's another different approach. So as you can see, being flexible with these is certainly advantageous. Let's look at another one. Let's go for this one. Let's see what we got. 8. Let's go for 8 is equal to 4x plus 2y. And then we've got now x is equal to 2 minus 3y. The first thing I'm thinking to myself is that we could divide equation 1 by 2. If I do that, I'm going to write that 4 is going to be equal to 2x plus 1y. So that's what I do. If I divide this equation now by 2, we can go ahead and write it like so. So that becomes equation 1. Now you might think to yourself, well, that doesn't really help. But what we could do at this stage is now find an expression for x in terms of y and simply substitute this in. So if I know that x is equal to 2y minus 3, I can write equation 1 as 4 is equal to 2, and instead now of the x, I'm going to write 2 minus 3y, and then we're going to have plus y. So all I've done is taken equation 1 and substituted this in. So 4 is going to be equal to 4, then we're going to have minus, and we'll have minus 6y, and then we're going to have plus y. So we can see from here that 0 is going to be equal to negative 5y, so y is going to be equal to 0. We can substitute that back in, substituting it back into the second one. X is going to be equal to 2 minus 3 lots of y, so we can see x is going to be equal to 2. Do they work? Well, let's have a look at this one right here. 4 is equal to 2 lots of x. Well, that's going to give me 4 plus 0, so it works for that one as well. So that's one approach. With that equation, there's lots of different ways that you could do it. Let's really make a mess of this and show how you could you can get around these anyway. So let's have a go at this again, but I'm going to do it in a more convoluted way. So what I'm going to do with, let's just write this now, x is going to be equal to 2 minus 3y. I'm going to make here y the subject of equation 2. So I'll call this one 1 and I'll call this one 2. So I'm going to say that 3y is going to be equal to 2 minus x. And I'm going to say that y is going to be equal to 1/3 of 2 minus x. So this now becomes equation 2. So what I'm trying to do here is show that whichever way around you go, however messy it is, it's going to come up with the same thing. What I'm now going to do is substitute that in just here. So I'm going to say in equation 1, 8 is equal to 4x plus 2y. Well, this is y, so that's going to give me 2/3 of 2 minus x. At this stage, I'm just simply going to multiply the equation by 3. So we've got 24 is equal to 12x plus, expanding the brackets, 4 minus 2x. So from here, what we can say is the following. We've got on here that subtracting the 4 from both sides, 20 is going to be equal to 12x minus 2x, which is going to give me 10x. Dividing both sides by 10, x is going to be 2. So we can see that that works that way. Now if we substitute in x is equal to 2 here, 2 minus 2 is going to give me 0, 1/3 of 0, y is going to be equal to 0. So even making this a horrible fraction, we can see that if we really needed to, we could make y the subject and substitute in. I personally wouldn't do it that way, but on some equations it can be easier to make one of them the subject and go ahead and substitute in. So that's looking at solving simultaneous equations a couple of different ways on top of your method of elimination. So it's rearranging and then some substitution.